this study, funded by the BIAL, my colleagues and I examined for the first time the temporal dynamics of size constancy for action and perception as it operates in the real world. Size constancy can be defined as the human ability to recognize and treat an object as having the same size, despite the fact that the image on the retina changes continuously with viewing distance. For example, as we watch a train depart from a platform, the image of the train on the retina gets smaller and smaller as viewing distance increases. Nonetheless, we do not see the train shrinking in size, but rather moving away from us. Size constancy is important not only for maintaining a stable perceptual experience of the external world, but also for guiding object-directed actions such as grasping. To successfully pick up an object, our visual motor system needs to scale the grip aperture according to the true size of the object, and this cannot be affected by viewing distance. So here we devised a novel methodological approach to understand when the brain is able to combine together retinal image size and viewing distance information for the purposes of size constancy. To this aim, we registered together the electrophysiological activity of the brain by means of an EEG system and the kinematics of the hand by means of a motion tracking system. Meanwhile, participants were involved in two different tasks: a manual estimation task, where they had to manually indicate the perceived size of the object, and a grasping task, where they had to reach out and pick up the same object in a natural manner. These two tasks are thought to be subserved by different neural pathways in the brain. The stimuli consisted of 3D real discs, which were placed at different viewing distances. Importantly, the size of the disc was scaled according to distance in order to attain the same retinal image size. Our results revealed that the first positive going component that we were able to record, namely the P1 component peaking approximately at 90 milliseconds after stimulus onset, was already modulated according to size constancy principles. This demonstrates that size constancy occurs at the earliest cortical stages. Also, our results demonstrated that effects related to the task were observed only later in the processing of visual information at the level of the P2 components. These findings are better described in a paper that we recently published in Neuropsychology. If I had to define the BIAL Foundation in a word, it would be invaluable.